Hello everyone. Today we're going to learn rational numbers and their decimal expansions. So there are basically we have rational numbers and for rational numbers there are two types of rational numbers. Like first one, generally we write the rational numbers as ratio of two integers, right? Where q is not equal to 0. But we in this also we can segregate this into two types. One type of rational numbers are those which are terminating terminating and second type is non-terminating. Okay, so today we are going to see how to identify the rational number if it is terminating or non-terminating. There are different ways to figure out. Okay, well, let us see that with some example. Like for example, let us say 0.375. I want to find if this is, obviously this is a rational number, and whatever we are going to look at, they will be rational numbers only, but we are going to figure out if they're terminating or non-terminating. Fine. Okay then, so this can be written as very easily 375 divided by 1000. Correct. It can be written further as 375 divided by 10 cubed. Correct. And this 375 can be written further as 5 multiplied by 75. Yes. 5 multiplied by 75 is 375 upon 10 cube. This can still be further simplified. 75 is how much? 5 into 15. So 15 multiplied by 5 multiplied by 5 by 10 cubed. Correct. And this can further be written as 3 multiplied by 5. This 15 can be written as 3 multiplied by 5 divided by 10 cube. Correct. Now what do we understand from this is this is the simplest form we got it, like 5 multiplied by 5 multiplied by 5. So it is 5 cubed upon 10 cubed. Okay. So finally I can write this as 2 cubed multiplied by 5 cubed. Correct. I'm talking about this 10 cubed. I can write 10 cubed as 2 cubed multiplied by 5 cubed. And when we cancel this 5 cubed, what is remaining is 3 by 2 cubed. That is 3 by 8. Fine. So basically, we got to know that this 0.375 can be written as 3 by 8. Okay. Now, this 3 by 8 is our P by Q. It is a rational number. Similarly, if we talk about one more example, let us take one more example. C 0.104. Okay. So now this can be written as 104 upon 1000 because we have 3 digits after decimal. And this 104 can be written as 13 8s are 104 and 1000 is 10 cubed. And then 13 multiplied by this 8 can be written as 2 cubed. And in denominator we have 10 cubed, which can be written as 2 cubed multiplied by 5 cubed. Now 2 cubed is cancelled. That's where we get 13 by 5 cubed. Or you can also write it as 13 by 125, which is again P by Q. Correct? So what are we observing here? What are we observing? If you see this is a rational number in decimal form. This is also a rational number. It is also in decimal form. But they're terminating, right? We have stopped here, like it is terminating because I'm having only 3 digits after decimal. Here also it is terminating. Correct. So what do we understand? what is the common thing which we have? Okay, for coming to conclusion, let's take one more example. Okay, it's better to take one more example. Let me take an example of okay, 0.0875. Let me take example of this. Okay, so now this will be 875 divided by 10000. This depends on how many digits are there after decimal. Okay, so now this can be written as 875 divided by 10 power 4, and this further can be written as 7 ones are 7 to 5, 35, 7 to 14, 317, 1. Okay, yes, 10 power 4. So 7 multiplied by 125 can be written as 5 cubed upon 10 power 4 can be written as 2 power 4 multiplied by 5 power 4. Now out of this there will be only 1 5 will be remaining, 7 upon 2 power 4 multiplied by 5. Okay, so this cannot be simplified further, so we can keep it as it is, or we can write it as 16 5s are 80, so we can write it this way, P by Q. So in all the three examples, we were successful in getting a form where you can see what is P and what is Q. If suppose if I'm willing to write any rational number in the form of P by Q. But what is common thing, what we've seen in three examples is, let's go up a bit. Okay, if you see, like before converting it, like before writing in a simplified form for P and Q, we can see that, let me take a red color to explain this, it's very important thing. This thing, what do we see? We have 2 as the factor, prime factor, and in second we have 5 as the prime factor, and in third we have 2 as well as 5 as the prime factors. So and all the three examples are terminating examples, correct? They all were terminating digits after decimal. So there is a relation between if the digits are terminating and the denominator is having prime factors as 2 and 5. Yes, there is a relation. Okay, because we are taking multiples of 10, correct? See, this is 10 cubed, that is multiple of 10, 10 power 4 multiple of 10. So therefore we bound to have denominator as denominator having the prime factors of 2 and 5, correct? So what do we conclude from this? If we have a rational number P by Q where Q is not equal to 0, and if Q, the denominator, is having prime factors as 2 and 5 with some powers, we don't know what powers they have, okay, where N and M are non-negative, okay, N and M are non-negative. In this case, we will always get a number which is having terminating digits after decimal. So this is a quite interesting fact. Okay, I'm repeating. If you have a rational number which you generally write in the form of P by Q, where P and Q are integers and Q is not equal to 0, but from that, if the denominator is having prime factors as 2 and 5 with some powers, some non-negative powers, then you can definitely say that the rational number what you are getting, I mean the decimal number which you are getting is non-terminating, sorry, terminating. Okay, so this is a good fact we know now. So whenever we have a rational number, we can easily will be able to say if it is terminating, if it is not terminating. Okay, only we have to check is the prime factors of denominator, if they have 2 or 5 or both. Like in the first example we had only 2, in second example we had only 5, in third example we had 2 and 5 both. So that is the condition. If we have 2 as the prime factor, if we have 5 as prime factor, and if we have 2 or 5, then we can say that they are terminating rational numbers. Uh, okay, people are joining now. Aryan, is this okay? Hello, Mahindra. Aryan, hi. Hi. Okay, Garima Khatkar. Okay, fine then. Let's go back to this concepts now. So now you're understanding. We are only looking at two things today. One is the terminating rational numbers, how to identify them, and second one is the non-terminating rational number and how to identify them as well. Okay, so first one we've seen that how to identify the terminating rational numbers. We just have to take the denominator, check if they are having prime factors as 2 and 5. Even if they are having a power of 2 and 5, that is fine. Either 2 or 5 or both, one at the same, they all will be terminating rational numbers. Fine. Okay, so from that we get a theorem which says I mean, I'll have to write the statement, but I'll just read it out. Basically this thing what I wrote here, this is a summary of that theorem. It says if the rational number whose decimal expansion terminates, then it can be expressed in the form of p by q. That means this, where q is not equal to 0, and q will have prime factorization of 2 and 5. I mean this. So that's what they are trying to tell us. Okay, now let's talk about non-terminating uh, rational numbers. Okay, let me go back to the blue color. Non-terminating rational numbers. Okay, suppose, let me take an example of 1/7. Okay, so if I want to divide this, okay, let us divide this. Let us see what we are getting. Let us take a long form of division. When I take decimal, we get 0. Then 7 ones are 7. We have to subtract, we'll get 3. And we have to take 0 because we have decimal. Now 7 fours are 28. Let's go down a bit. So on subtracting, this will give us how much? This will give us 2. Correct. And again, we will put 0. Then 7 twos are 14. We get 6 on subtracting, and we get 0. So 7 eights are 56. On subtracting, we get 4, and we put 0. And then 7 fives are 35. 5 0. And then 7 sevens are 49. Subtracting, we get 1 0. If you see, this is again repeated. Correct. So this process is going to repeat again. That means these numbers are going to repeat again, like 0.142857. Again it will start 142857. Again it will start 142857. In that way it will continue. Okay, so this is very important. I'll just show you with the red color. We started with 10 and we again reach the same point. So the process what we got in this direction will be repeated. Okay, so therefore we say that it is non-terminating rational numbers. Okay, so what do we see that? Wait, go back to my blue color. Fine. What do we see here? This is of p by q form, correct? Where p and q are integers. Q is not equal to 0, obviously. Now look at q, the denominator. It is neither having 2 as prime factor or 5 as prime factor, but we have 7. So what we can conclude from here, that if we have a rational number p by q, but q is not equal to 0, and if q is having prime factorization, I'm writing in short, prime factorization of 2, prime factorization of 2 and 5, should I say that? Yeah, 2 and 5, then it is terminating. But if prime factorization of other than 2 and 5 uh, not equals to 2 and not equals to 5, okay, so I should not write in this way. I should write other than, so it's better to prime factorization other than 2 and 5, other than 2 and 5. They're having prime factorization but other than 2 and 5. In that case, you will get non-terminating rational numbers. It's so easy, correct? We'll just go through what all we have seen just now. We have seen that rational numbers, we're talking about rational numbers today and their decimal expansions, okay? And we've seen that we write rational number in the form of a ratio of two integers, but they are having two types of rational numbers. One is terminating and second one is non-terminating, okay? Now the question was how to identify which one is terminating and which one is non-terminating, okay? So how to identify? Whenever you are given with a question, you check the denominator. You check the denominator. Like we have taken few examples. We have taken example number 1, and then we have taken example number 2, and then we have taken example number 3. And in all the three examples, we have observed that the denominator is actually having a prime factor of 2 or 5 or both. Like in question number 1, we had only prime factorization of 2, and in question number 2 we had prime factorization of only 5, and in 3 we had prime factorization of 2 and 5 both. So in this scenario we can say that the rational number which we are getting is having a terminating form, okay? So therefore we came to this result that whenever you have a rational number, if denominator is having prime factor of 2 and 5, it can be of any power, then n and m are non-negative anyway, then that rational number is terminating. What about non-terminating? Exactly what we have seen here from the question. We have taken an example of 1 upon 7 and we have seen that it is repeating, therefore it is non-terminating. But what fun fact we figured out here is that its prime factorization, the q in this case is 7. 7 is a prime number. So other than 2 and 5, if you have prime factorization of other than 2 and 5, then you can say that those rational numbers are non-terminating. So let us take few examples to figure out if they are terminating or non-terminating, okay? So as we move on, I just want to remind you that if you are not subscribed, then please subscribe and press the bell icon to not miss any update from us. And you can also visit our website www.letstute.com for a wide range of courses on science and maths, okay? Okay, let's take a few examples. Video is not visible. Is video is visible? Give me a second. It's, I guess, having a, just check one more time. Give me a second. I'm just trying to fix this issue. Okay, now it's fine. It's visible, I guess. Hi, Gaurav. Okay, yeah, it will be available. Okay, fine then. So we are talking. We are going to check if check with some examples that how to figure out if the rational number is terminating or non-terminating. Let us try with some examples like 17 over 8. Of course, this is a rational number. It is a ratio of two integers, 17 and 8, and we have to check if it is terminating rational number or not. Okay, and the condition is if we have to check the denominator if they are having prime factorization of 2 and 5, 2 or 5. Okay, so let us start with let me write it here only. 17 is itself is prime. Okay, and what about 8? 8 can be written as 2 cubed, correct? So this is 17 upon 2 cubed. So we can see that denominator is prime factorization of 2, correct? So therefore it is terminating. Terminating. If people are joining now, let me tell you, if the denominator is having factors 2, 5 or their powers, then we can say that it is terminating. If we have other than 2 and 5, we can say they are non-terminating, and we have seen the results of these things just a little while ago. Okay, let us solve some more questions. These are the examples. 15 upon 1600. So this can be written as 3 multiplied by 5 in the numerator, that is 15, and in denominator we can write it as 16 multiplied by 100, that is 10 squared, correct? 100 is 10 squared. So 3 multiplied by 5, and 16 is 2 power 4. Okay, and 10 squared is 2 squared multiplied by 5 squared, correct? So now this will be 3 multiplied by 5, and 2 power 4 multiplied by 2 squared, it will be 2 power 6, and 5 squared. So this 5 will be removed, or you can say cancelled, okay, because we have common factor. So 3 upon 2 power 6 multiplied by 5. Okay, so now you can see that denominator is the having the factors 2 and 5, correct? So 2 power 6 and 5 are the factors of denominator. Therefore we can say that it is terminating. It is terminating. Okay, so that's what we got it from here, correct? So let's take one more example. Twenty-three upon 2 squared, sorry, 129 upon 2 squared, 5 power 7, and 7 power 5. Okay, 129 can be written as 3 uh, 3 3 343. Okay, let me just, okay, 3 multiplied by 43, and 2 powered 2, 5 powered 7, 7 powered 5. Now you can see that we have the prime factorization over here. 3 and 43 both are prime numbers. And here, if you see that we have 2, we have 5, but we have 7 as well. We need only 2 and 5 as the factors of denominator. Then only we can say that it is terminating. Since we have 2 and 5 and extra 7 also, we say that it is non-terminating. It is non-terminating. Okay, fine. Let us go for one more example. 35 upon 50. Okay, so this would be what? 35 is 7 multiplied by 5, and this is 10 multiplied by 5, or we can also write it as uh, 25 multiplied by 2. Correct? So this would be 7 multiplied by 5 upon 2 multiplied by 5 squared. So anyway, 1 5 would be cancelled. So we will have 7 by 2 multiplied by 5. Now we can see in the denominator we have the prime factors as 2 and 5. In this case, we say that it is terminating. That's what we are learning from the beginning. When we have the factors of denominator as 2 and 5, or the powers of 2 and 5, then we say that the rational number is terminating. Okay, so hope you're understanding. Yeah, okay. Let us solve with some more questions. It is short topic, that's why it's been explained already, and we are trying to solve few questions so that we are aware that what we are doing. 77 upon 210. Okay, we have to check if it is terminating or non-terminating. We can write 77 as 7 multiplied by 11. Both are prime numbers. And 210 as 21 multiplied by 10. 7 multiplied by 11. And here 21 multiplied by 2 into 5. So here we see that 7 3s are 21. So this becomes 11 upon 2 multiplied by 3 multiplied by 5. So 2, 3 and 5 are prime factors, correct? But we wanted 2 and 5, but we also have 3. So because we have one extra prime factor than 2 and 5, we can say that it is non-terminating. So it was very easy to figure out if they are terminating or non-terminating. We just have to figure out what are the prime factors what are the only prime factors of denominator. If they are 2 and 5, then we can say that it is terminating. If not, it is not terminating. Okay, and we can say one more question, then we can uh, finish this off, because it's very short topic to start with and to finish with. We have 6 upon 15. So that can be written as 3 multiplied by 2, and we have 3 multiplied by 5. Okay, so 3 and 3 got cancelled. We have 2 upon 5. You can see that we have 5 as the prime factor in the denominator, so we can say that this number 2 by 5 is terminating. What we are getting, by the way, 2 by 5 is nothing but 1 upon, sorry, 2 upon 5 is 20 40 40 0.4. Yeah, 0.4. So we can see that we have terminating decimal number. So that's it for today. If you have not subscribed, please subscribe and like and share and press the bell icon to not to miss our update for any video. And you can visit our website www.letstute.com for a wide range of courses on science and maths. See you next time with a new topic. Till then, take care. Bye bye.